Hello students, welcome back to my channel once again. In the previous video, we have solved question number 32. Now we are going to solve question number 33. So let us take a look. Find the zeros of the quadratic polynomial 7y square minus 11 by 3y minus 2 by 3 and verify the relationship between the zeros and the coefficient. Okay. So let us first write the quadratic equation. 7y square minus 11 by 3y minus 2 by 3. So we know that the zeros of the quadratic equation we need to find out, right? So that means this quadratic polynomial will be equal to 0. So now let us simplify this. If we do the LCM, then it will become 21y square minus 11y minus 2 by 3 equal to 0. In turn, we can write 21y square minus 11y minus 2 equal to 0. So now let us do the factorization. So 21y square and this is 21 and this is minus 2. So which becomes 21. If we do this is our A, this is our B, this is our C, right? So A multiplied by C is minus 42, right? So minus 42, now we have to make minus 11, right? So what are the factors of 42? For 42, we can write as 6 multiplied by 7, or we can write 3 multiplied by 14. So 6 multiplied by 7 doesn't give you minus 11. 3 multiplied by 14, yeah. So this gives us 11. So if we do subtraction, then it will give us 11, right? So now let us do the factorization. Why we need to do subtraction? Because A multiplied by C, look at the sign over here, it's negative. So negative indicates that we need to do the subtraction. So 21y square, and we have to, since here the sign is minus, so we have to take the bigger value as minus 14y plus 3y minus 2 equal to 0. So now from here we can take 7y, then 3y minus 2 will be remaining, and now here we will take common as 1, so 3y minus 2. So it is coming 3y minus 2, 7y plus 1 equal to 0. So that means y value can be 2 by 3 or it can be minus 1 by 7. Isn't it? Like 3y minus 2 equal to 0, that means y equal to 2 by 3. And 7y plus 1 equal to 0 means y equal to minus 1 by 7. Okay. So these are the two zeros of the polynomial, right? Or the quadratic equation. Now let us do the problem in the next page. Okay, now what we already got, A as 21, B as minus 11 and C as minus 2. So let us write that first. A equal to 21, B equal to minus 11 and C equal to minus 2. So how we get that? By comparing with A square plus BX plus C equal to 0. This equation, if we compare with the our quadratic equation, then we can write that A the coefficients of A and B and C. Now, what are the alpha and beta? That is the zeros that we already got is 2 by 3 and minus 1 by 7. So, what is the question that we need to find the relationship? We need to uh, verify the relationship. So, let us first write the relationship. So, we already know that sum of zeros that is alpha plus beta. So, let us put the value first. So, sum of zeros, we already know the relationship between sum of zeros with the coefficient is alpha plus beta equal to minus b by a, right? So, this we already know, but we need to verify it over here. So, let us take a look how we are going to verify. So, alpha plus beta will be 2 by 3 plus minus 1 by 7. So, if we do LCM, 21 is 14 minus 3. So, it is coming 11 by 21. Okay, so if we, this is our left hand side. Now, in RHS we have minus b by a. So, what is the value of minus b? Minus 11 and a is 21. So, which is coming 11 by 21. So, we can clearly verify that. So, alpha plus beta equal to minus b by a, verified. Okay, but we have another relationship, that is alpha beta, that is the product of the roots, is equal to c by a. Okay, so let us verify this now. So product of zeros, that is alpha beta, equal to 2 by 3 into 1 minus 1 by 7. It's coming minus 2 by 21. Now c by a, c is minus 2, a is 21. So what we got, that alpha beta is equal to c by a. So this is also verified, hence verified. Okay, so we have verified both the relationship with the zeros, the coefficient of the quadratic equation. Okay, hope this is clear to you. See you in the next video with the next question.